I'm going to be building this 65P single-ended amp designed by Doug DeYoung at Bug Amps. It has a transformer input, as you can see, transformer output. The 65Ps will be triode strapped, and that's one channel. And the power supply and the parts I've got so far, there are the output transformers, power transformer, and the tube sockets, and I'm playing with the layout right now. That's going to be the footprint. Input transformers, I'm thinking about going balanced. I haven't decided 100% yet for the input. Of course, the speaker outs and the IEC, and I like to use filtered. And I haven't built the power supply yet because I don't have all the parts, so I'm kind of deciding I'm going to use one of these two boards depending on the amount of space that I need. Well, the enclosure is going to be made from 22 gauge steel. And this is 12 inches by 18 inches. That'll be the main body. And I'm going to use this brake to bend it, and the end caps will be this hardwood flooring. I just took two scrap pieces and glued them together, and I'll cut them to fit the end caps once I get the enclosure formed. Now I've got the return bins laid out right there and there. So I'll make those first, and then I'll make the main bins, which will be right in here. But the enclosure is going to be 3 inches tall, 12 inches wide, and a little over 10 inches deep. Now for the first bend, and this has to be clamped in extremely well. Now we'll go ahead and pull this up. And you can get a reasonable. Now I'm going to make the second return bend. Let's see. Now for the main bend, you have to clamp it a little differently because that return bend will come up and hit the clamp. So it's all lined up. And now to make the final bend, and one thing you really should do when you're deciding which side to form is to look closely at it and save the best side for the outside. So if there are any blemishes or anything like that, just put those onto the inside, because it's clamped. Okay, so now I've got it formed. I'll make another plate to go in here, and which that'll be the bottom, this will be the top, and the end caps will be the hardwood flooring. Well, I've started the assembly. I've already got the power supply in. It's not tightened down, but it's just in loosely. And I'll put the end caps in. And well, I've got the end caps and the power supply in. So of course now we'll get down to the serious wiring. Well, it is together, and in my system it sounds pretty good, but I was noticing a little bit of high frequency loss, and you can see on the square wave here I'm getting some rounding, and that equals to, at about 10 kilohertz, about 3 or 4 decibels of loss, and at 20K a lot more than that. I mean, like 8 decibels. So as an experiment, I tried lowering the input impedance from 600 ohms to 150, and you can see that flattened out the curve. So the problem is that the input transformers I'm using just can't handle that. So I'm going to look at putting in different input transformers and see how that goes. Well, I've got the Cinemag CM2560 transformers in, and they're testing pretty good. Right now I've got a 615 ohm load on the input and a 220K load on the output, which will emulate the real life conditions. You can see I've got a little bit of ringing right there, but I can take that ringing out by just putting a 68 picofarad capacitor across the load right there, and it made it almost all go away. So I want to install these into the amp and then see what happens. Now this is spec'd at 2 watts per channel, so we'll see how far it goes before clipping. I'm going to use a scope to monitor the waveform, but I want to check the actual voltage with a millivolt meter. It's just more accurate for voltage level. So I'll start turning it up. It's like right there we're starting to see some clipping, so back it down just a bit. And that's about 3.4. I've got it in my system now. There's the back where everything's hooked up. I'm getting a little help from Tracy Chapman. Turn the volume up a little bit. Crying at the doorsteps of the longings of salvation.